Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 322, coin change. The goal is to determine the minimum number of integer combinations that sum up to the given target using only the numbers in the provided array and return either discount or -1 if it's impossible. At first glance, it might feel like a greedy approach would work, but there is a catch. What should we do? Let's say you are at the top of the castle. If you need to know how many stairs you need to take to get to the top, how would you find that out? Well, you can ask the people who are coming up to the top. Sounds silly, but hear me out. Dynamic programming essentially involves dissecting intricate problems into manageable pieces, calculating each piece once, and storing those calculations to avoid redundant effort. There are two key attributes that a problem must have in order for dynamic programming to be applicable: optimal substructure and overlapping subproblems. Optimal substructure means that the solution to a given optimization problem can be obtained by the combination of optimal solutions to its subproblems. Overlapping subproblems means that the space of subproblems must be small, that is, any recursive algorithm solving the problem should solve the same subproblems over and over rather than generating new subproblems. Let's try this way. If we split down the problem until it is an unsplittable atom-sized problem, we can see the whole problem consists of these atomized problems. So until we reach our goal, we will relay the subproblems by solving one problem and pass its result like a button to the next problem. Likewise, use the minimum number of coins required to reach the target amount at each stage. If we have an infinite number of coins of 1 and 2, then we are rich. What are you talking about? And our target amount is 4, for example. Don't jump into the target amount 4 right away. Start from 1 as if it's like the target amount. So what is the minimum number of coins for target amount 1? It's simple, just a coin of 1. How about for target amount 2? In that case, a single coin of 2 or 2 coin of 1 would work. We will choose a single coin of 2 because it's the minimum number of coins. Before we continue, let's give some time to think about making up target amount 2 with the coins of 1. Actually, we can compute this with 1 coin of 1 and the minimum coin numbers of the remaining amount. So in the case of target amount 4, we will choose the least side between 1 coin of 1 plus the remainder except of it and 1 coin of 2 plus the remainder except of it. In short, we need an array initialized to a very large number, except for the index 0, that can represent each step to the target amount. And for each amount, we will record the minimum number of coins needed to make that amount, with each coins in the array, and use this to build up what the minimum value for the target amount will be. Finally, regarding optimization, For each given coin, we do not necessarily need to check from 1 to the target amount, but can set the range from the amount of the coin to be used to the target amount. For example, when trying to make the target amount 11 with coins of 11 and coins of 13, checking if it is composable from target amount 1 is redundant. Also, rather than checking for the target amount for each coin, it is more efficient to set the range as the target amount minus the value of the currently used coin. Taking it a step further, if we sort the coin in ascending order by price, we can conjecture that we can complete the check on each coin by simply setting the upper bound of the range with the least common multiple of each coin and the next. However, is it because of optimizations of JVM, or is it because the size of the test cases is not large enough? As for the upper limit of the range, running with the target amount given in the problem without further notification showed the fastest speed. Oops, too much talk. Let's code it up. With an array initialized to large numbers to make it easier to distinguish except index 0. For each coin, the range from the coin price to the target amount. Record whether the minimum number of coins can be made by adding one more coin corresponding to the target amount. If there is a way, at the target amount, the number of coins must be smaller than the target amount. Let's run the code. That's it. When you encounter problems like finding optimal ways to do something, minimizing, maximizing certain values, or checking if some pretty complex job is possible in a limited time sort of thing, you might want to cross your mind to use dynamic programming.